Hey guys, I'm Daniel. And today we're getting into loop quantum gravity, also known as LQG, and attempting to explain it as simply as possible. Not an easy task, but I'm going to try my best. Imagine a universe made entirely of Lego bricks. Each brick is a fundamental building block, and when combined, they create everything we see around us. Houses, cars, even spaceships. In a way, that's how loop quantum gravity, or LQG, views the universe. But instead of Lego bricks, we have something even more fascinating: loops. These loops are not made of plastic, but of something much more fundamental. They are the very fabric of space-time itself. Just like Lego bricks connect in specific ways, these loops join and weave together, forming a complex network that underpins the reality we experience. This network is dynamic and ever-changing, constantly buzzing with quantum activity. This view challenges the traditional picture of a smooth, continuous space-time proposed by Einstein's general relativity. Instead, LQG proposes a universe built on a quantized framework, where space and time are not infinitely divisible, but come in discrete chunks, much like the individual Lego bricks in our analogy. In our imaginary Lego universe, the size of the smallest brick limits how we can build. We cannot create structures smaller than that fundamental unit. Similarly, LQG introduces the concept of atoms of space and time, the smallest possible units of these fundamental entities. These atoms are incredibly tiny, far smaller than anything we can currently observe directly. These atoms of space and time are not like the atoms we learned about in chemistry class. They are not made up of protons, neutrons, and electrons. Instead, they are the fundamental building blocks of space-time itself, the stage upon which all of physics plays out. Their existence implies that space and time are not smooth and continuous, as our everyday experience suggests, but rather granular and discrete. To visualize this, imagine zooming in on a seemingly smooth surface, only to discover that it's actually made up of countless tiny dots. That's what LQG suggests about the fabric of reality itself. This granularity, however, only becomes apparent at the Planck scale, an unfathomably small size where gravity's quantum nature becomes significant. Now, let's talk about how these atoms of space-time connect. Remember the loops we mentioned earlier? These loops are not just abstract concepts. They represent lines of force that weave together to create what we call spin networks. These networks are the very essence of space itself in LQG. Each loop carries a quantum of area, and each connection point, or node, carries a quantum of volume. Imagine a flipbook animation. Each page represents a snapshot of the spin network at a particular moment. As you flip through the pages, the network evolves, loops connect and disconnect, and space itself seems to breathe and change. This dynamic, ever-evolving network is the stage on which the drama of the universe unfolds. These spin networks are not static. They constantly fluctuate and interact according to the laws of quantum mechanics. These quantum fluctuations give rise to the fabric of space-time as we know it, with its curvature, expansion, and all the fascinating phenomena we observe in the cosmos. Understanding the dynamics of these spin networks is one of the key challenges in LQG. The beauty of LQG lies in its elegance. It attempts to unify general relativity and quantum mechanics, the two pillars of modern physics, into a single, coherent framework. While general relativity excels at describing the universe on the largest scales, planets, stars, galaxies, it stumbles when applied to the microscopic realm of black holes and the Big Bang. Quantum mechanics, on the other hand, reigns supreme in the microworld, explaining the behavior of atoms and subatomic particles. However, it traditionally treats gravity as an afterthought. LQG attempts to bridge this gap by providing a quantum description of gravity itself. It suggests that gravity is not just a force, but an emergent property arising from the interactions of these fundamental loops and nodes. LQG offers a fresh perspective on some of the most profound questions in physics. For instance, what happens at the singularity of a black hole, where gravity becomes infinitely strong? What happened during the Big Bang, the event that birthed our universe? LQG suggests that the quantized nature of space-time might prevent these singularities, offering a more nuanced and potentially less paradoxical view of these extreme events. LQG is still a work in progress, a theory under construction. Many challenges remain before it can be considered a complete theory of quantum gravity. One of the biggest hurdles is developing experimental tests that can verify or refute its predictions. The Planck scale, where LQG's effects become significant, is far beyond the reach of current experimental capabilities. However, despite these challenges, LQG has already yielded some intriguing insights. For example, it suggests that the Big Bang might not have been the beginning of time itself, but rather a big bounce, a transition from a previous collapsing universe to our expanding one. This intriguing possibility arises from the quantization of spacetime, which prevents the singularity predicted by classical general relativity. Furthermore, LQG offers new perspectives on the nature of black holes, suggesting that they might not be the eternal prisons we once thought, but rather dynamic objects with a complex internal structure. These are just a few examples of the potential of LQG to revolutionize our understanding of the universe. Loop quantum gravity invites us to imagine a universe far stranger and more wondrous than we ever imagined. A universe where space and time are not smooth and continuous, but woven from the threads of quantum loops. A universe where the seemingly solid ground beneath our feet is, at its core, a seething, bubbling quantum foam. While LQG is still in its infancy, it offers a tantalizing glimpse into a deeper reality, a reality where the universe is not a passive stage, but an active participant in the quantum dance of creation and annihilation. As we continue to explore the implications of LQG, we embark on a journey that promises to push the boundaries of human knowledge and reshape our understanding of the cosmos and our place within it.